8.4 is on solving logarithms, at least solving basic logarithms. This is actually something we've kind of already done. We've talked about converting and about simplifying or evaluating. Well, if I just convert this, if I convert this from log form to exponent form, I end up with 4 to the second equals x in that conversion. 4 to the second equals x. Well, now the x is by itself, so I know that x equals 16. I've solved the equation, I know what x is. Whenever you're solving, your goal is to find the variable. So here I convert 8 to the 2/3 equals x. Remember, I call that the circle thing. Well, 8 to the 2/3 I could do in my calculator. I know it's going to be 4 though, because this means the third root of 8, and the third root of 8 is 2, and this means 2 squared is 4. So I get that 4 equals x. But if you want to, 8 to the 2/3, 4. Beautiful. With one log, you just convert. It's pretty straightforward. The book shows another way of doing this that I'll explain at the end of this video. I think it's kind of silly and pointless, but also something you should see. 2 logs. Well, this problem is going to end up being really similar. Remember, we've done problems with common base. We have something like this. And the idea is, if 3 to the 5x is the same as 3 to the 2x plus 1, if they're actually equal to each other, the only way that this can equal this is if the powers equal each other. So we can actually just kind of drop the bases of 3 and solve for the powers from here. We would get that 3x equals 1 and x equals 1/3, and that would be our solution. But we can just drop the bases because they were the same. We can really do the same thing over here. These both have the same base. They're both base 10. Well, the only way that this number here, this is just some number, the only way that this number can actually equal this number is if the stuff inside the parentheses is equal. So you can really just drop the logs, subtract an x from both sides, and 4 equals x. So over here, these have the same base. Let's switch color now. These have the same base, so I can just drop the log. And now this is a quadratic, so I just solve it like a quadratic. I'm going to subtract 2x from both sides and add 2 to both sides, and I get that x squared minus 3x plus 2 equals 0. Well, this can factor really well. It's x minus 2, x minus 1, which means that my solutions are possibly 2 or 1. Now this can definitely have extraneous solutions, solutions that might not actually work. It is possible that they both work. So I'm going to see if there's any reason this couldn't make sense. I'm going to plug them in. If I plug in a 2, 2 squared is 4, and 4 minus 2 is 2. I have log base 8 of 2. And log base 8 of 2 is actually 1/3. Don't worry about that right now. I'll teach you to calculate that later. I plug in a 2 here, I get 4. 4 minus 2 is 2. I have log base 8 of 2 again, and that's also 1/3. So this one's good. If I plug in a 1, I get log of 0, and I can't actually have a log of 0. 0 is not in our domain. Remember, these graphs have vertical asymptotes. 0 doesn't fit in the domain, so this one doesn't actually work. That's my only solution. The way that the book would have you handle problems like this, excuse that problem. Remember, these are both base 10. There's a property of logs that says if I took 10 to the log base 10 of x plus 4, that would just equal x plus 4. And if I did 10 to the log base 10 of 2x, that would just equal 2x. So really what the book would do is take both of these sides to the 10th power, and then drop the logs. So I'm just skipping that step in between and going from there, but I'll talk about that a lot more later. Thank you.